This is a continuation of our trigonometric equations video section. So now let's consider a situation like this. Sine of x times cosine of x is equal to 1/2 with our familiar restriction that x lies between 0 and 2 pi, not including 2 pi. Okay? So we aspire to solve for x in this situation. Notice that taking the sine inverse of both sides won't help, because the sine inverse function doesn't travel across multiplication. And so even if it got to sine, it wouldn't get to cosine. And a similar argument is for cosine inverse, because even if it gets to cosine, it wouldn't get to sine. So such a technique is not valid when you have a product of two different trigonometric functions. What we must do is, via some type of manipulation of this equation, convert it into just one trigonometric function, and then take the inverse function of that function to be able to solve for x. Recall the double angle formula for sine of x. Sine of 2x is equal to 2 sine of x cosine of x. Okay? Why is this on our board? Well, it's due to the fact that one simple manipulation to our given equation will allow us to arrive at that. And that's actually multiplying both sides by the number 2. When you multiply both sides by the number 2, you get 2 sine of x cosine of x is equal to 1, as you can see here. So once you get that, you may now set 1 equal to sine of 2x. Okay? So this is equal to sine of 2x. This is precisely what we want. We wanted our expression to reduce to one trigonometric function, because now I could take the sine inverse of both sides and proceed for solving for x. So then that would give me sine inverse of 1 is equal to 2x. Okay? So then we must find out what is the sine inverse of 1 equal to. Well, it's a question. It's asking at what angle does sine assume the value positive 1? And there's only one angle that it does this. That's at pi over 2 at 90 degrees. But note that we have to add a 2 and pi, because that is the period of the sine function. So now we have 2x is equal to pi over 4 plus 2 and pi. And to solve for x, we just divide both sides by 2. Okay? Okay, this is what we get. When the 2 distributes to pi over 2, I get pi over 4. And when the 2 distributes to 2 n pi, I just get n pi. So our x is equal to pi over 4 plus n pi. So let's find out what is x when n equals 0. Okay? So when n equals 0, all we get is just pi over 4. And pi over 4 lies within this domain, so it's an acceptable value. Alright? Now, what happens when n equals 1? Okay, well, I would get pi over 4 plus pi. Alright? This reduces to 5 pi over 4. And this is well within the range of the domain. Next, we'll plug in the next integer value. Okay? So then we have n is equal to 2. So I get pi over 4 plus 2 pi. Okay? Notice that pi over 2 added to 2 pi is clearly a value that exceeds 2 pi. So at n equals 2 and beyond, we do not accept these values as valid solutions to our equation. So our only solutions are 5 pi over 4 and pi over 4. To the original equation, sine of x cosine of x is equal to 1/2. Here's a proof. I'll plug in one of them. For x is equal to pi over 4, we should get sine of pi over 4 times cosine of pi over 4. We should hopefully get it equal to 1/2, or else we did something wrong. Notice that sine of pi over 4 times cosine of pi over 4 is the same thing as root 2 over 2 times root 2 over 2. Notice that this equals 2 divided by 4, which is precisely 1/2. Cha-ching. So we did it right, okay? You at home can go and practice plugging in 5 pi over 4, and notice that sine of 5 pi over 4 times cosine of 5 pi over 4 is also equal to 1/2. So when you get done doing these problems, you want to make sure you plug it back into your equation and make sure that you did it correctly for it to output the appropriate value in the equation for it to be a solution.